Welcome. Yeah, so it turns out that the Laplace transform of e to the at times f of t amounts to a horizontal shift by a on the Laplace transform of just f of t. So we're going to show this result in this video and also give an example. All right, now to start, the definition of the Laplace transform says this here, right? Okay, cool. Now here we're going to take this black f of t to be all of this, which is e to the at times f of t. And so apply the definition with the black f of t being e to the at times f of t. Yeah? Okay, cool. And that, by definition, and that's here, is the integral from 0 to infinity of e to the minus st. And as I said, the black f of t here is going to be all of this. So that is e to the at times f of t, and then dt, right? Okay, cool. And let's make that abundantly clear. So that what I circled here is that black f of t. Yeah? Okay, cool. And so there. Okay, cool. All right. Now we have some convenience right here, right? Because we can use exponent rules and say that this here is the same as just e to the st plus at. E to the minus st plus at. My bad. I forgot that minus sign in front of the s. But yeah, I'll write it down. Okay. Now, having this here, right, minus st plus at is the same as factoring out a negative and then factoring out a t and writing this here. Right? It's the same as what I had before. It's minus s times t and then plus a times t, once this minus sign and the t are distributed from the left and right respectively. So this is the same as this here, is what I'm saying. And of course then we have to write f of t dt after it, and so let's do that. Okay, cool. Now compare this here to this here, right? It looks like the difference between this here and this here is, instead of that s, we have s minus a, right? That's the only difference. That amounts to, instead of having this s here, putting an s minus a here. And that's what I meant by, at the start of the video, a horizontal shift, right? Okay, cool. So what I just said is, if we delete that s and instead put s minus a, that amounts to deleting that s right there and putting in an s minus a in place of the s, right? And that still has us retaining this negative, right? Like that. Okay, cool. So then this here now is identical to this here. So what we have here, as I've already said, is equal to capital F of s minus a. Yeah? Cool. All right. So this is it for showing the result, and let's look at an example. So the example is like, what if we wanted to do the Laplace transform of e to the 4t times sine 2t and do it efficiently? Now, in a video I've already made, I show you how to do the Laplace transform of sine 2t. So that's where you should start. And that is, the Laplace transform of sine 2t is 2 divided by 2 squared plus s squared, but 2 squared is 4, so it's 2 divided by 4 plus s squared. Yeah? And so since we have e to the 4t here, a is 4, right? Okay, yeah? Okay, cool. And so comparing those two, a is 4, as we said. And so that's that right there, yeah? So all we have to do is take this here, the Laplace transform of sine 2t, which is capital F of s, right? And then do s minus 4 instead of just s, right? So we see that capital F of s minus 4, that 4 was poor, is going to be equal to, well, that's just, instead of this s here having s minus 4, instead of that s there having s minus 4. So let's show that a bit deliberately. So again, instead of that s minus 4, instead of that s minus 4. And so here we are, final result. Yeah? Okay, cool. That's it for this video. Keep watching. Take care.